If you've started a research project, you may sometimes find yourself lost in information. So we're going to give you some tips and tools on how to be more efficient with your time during the research and inquiry process. The very first step in any good research project is to identify a research question that interests you. This comes before you develop your hypothesis. Your hypothesis is your potential answer to the research question you came up with, but forming a good research question is a bit more involved than you might think. In general, when you begin looking for a topic, you want to start with something broad, then gradually work your way down. To do this, think of a big concept that interests you. Then, narrow your scope so that you focus on a subset of that concept. Finally, set limitations and constraints so that your question is limited to a very specific, singular instance of that topic. For example, think of the following question. How does physical activity affect diabetes? Obviously, the scope of that question is pretty huge, so let's narrow each topic of that sentence down to smaller ones. What type of physical activity? And what type of diabetes? What about the population that you're interested in? When you narrow each of these fields down, you could come up with something like, how does endurance exercise affect type 2 diabetes in humans aged 50 and older? Keep in mind though, collecting your own data for this example question would require ethical approval for human testing. So here we're assuming a prospective study using existing data. With that out of the way, let's get into how to find information for your research question. It's important to recognize that you can't just type a phrase that comes into your head on Google. You might get some results, but remember, your goal is to find specific and relevant information for your particular research question. One of the best tools for doing this is to master the concept of keywords. As you can probably guess, keywords are simply words that capture a particular component of your research question. So in our example, some good keywords would be endurance, aerobic, high-intensity interval training, exercise, training, running, type 2 diabetes, diabetes mellitus, elderly, age 65. You get the point. Unfortunately, it's not quite enough to simply know what keywords you need. You also need to know how to combine them. Fortunately, there's a few mechanics that make this pretty easy. The first one is using quotation marks around a keyword or a group of keywords. When you put a word or phrase between quotation marks, you're telling the search engine to look for content that contains those words, in that order, exactly how you typed it. This can be really useful because search engines often break up what you type into the search bar to give you the most hits. Another great tool for specific online searches are Boolean operators, which allow you to combine your keywords to either include or exclude certain words to narrow or widen your searches. Some search engines have their own specific ones, but these are the main ones that you should know. Or, and not. Let's start with or. The or operator lets you tell the search engine that you want to look for content that contains either term 1 or term 2. For example, if you search for exercise on Google Scholar, you'll get about 2 million results. But if you search for exercise or diabetes, you'll get roughly 2.5 million results. The increase is because you've told the engine to look for articles that contain either exercise or diabetes, so the scope of your search has increased. More often than not though, you'll want to do the opposite, to filter out results to narrow your search, and that's what the AND operator is for. When you combine keywords with AND, you're telling the engine to only show you results that contain both keywords. Intuitively, this means that you'll get less search results with every addition of AND. Remember that you can combine multiple instances of AND to further narrow your search. Finally, sometimes you'll find that when you search for a topic, another irrelevant topic keeps popping up in the results, which can make finding the information you actually want difficult. The NOT operator is used for just this scenario. When a keyword follows NOT, you will exclude any and all results that contain that keyword. So let's say you want to exclude animal studies from your diabetes literature review. So in your searches, you add not animals to the end. Keep in mind though, there may be an article that you would want to see that ends up being excluded just because it says the word animal in the article abstract once. So proceed with caution. Now that you have the basic tools to search for information, hopefully you're asking yourself, okay, but where do I look? So far we've used Google Scholar as an example, but there are many, many more databases and search engines to look into, and no two databases will show you the same content. Ideally, you should find databases that contain the relevant research papers that pertain to your subject area, which is easy enough to do with, ironically, a quick Google search. That being said, some databases like Google Scholar and Web of Science contain a broader set of sources and can be used to research most topics. More specific databases include PubMed, Embase, and others. Finally, some closing remarks to put all of this into context. The words research and inquiry are largely used interchangeably as synonyms, but understanding the difference between the two can make or break your research project. When you do research, it's with the assumption that you know what you're looking for, and your goal is to find information to support your idea. But what if you only have a very general idea of what you're interested in? This is where inquiry comes into play. Inquiry is based on the idea of asking questions, sometimes even silly ones. The idea is that you start with a basic question, learn new things, and are then able to ask better questions. What if questions are particularly useful here? Consider this one. What if the sun rose in the west and set in the east? The obvious answer is, it doesn't. But if you really chase that line of thought and explored the implications of the sun rising in the west, you would learn so much about the Earth-Sun interactions implicitly, just by exploring this so-called dumb question. And that, ladies and gentlemen, is the essence of inquiry, the prioritization of understanding over memorization. Your goal as a student researcher is to learn, explore, and investigate. It can be all too easy to forget this when you're sitting there, poring over article after article, highlighting, note-taking, and memorizing. But don't lose sight of what research is all about, the quest for understanding core knowledge and using that knowledge to investigate new areas. If you keep this idea central to your work, you'll blow the socks off of anyone who comes around to take a look at your research. I promise.